Welcome, everybody. Thank you so much for being here. Happy SoSTEM. Woo! We are so excited that you are here today and that you and your fearless teachers have braved the snow in DC, which is always a struggle, I know. But we are so excited to talk to you all about the amazing things that we're doing with science and technology, and different careers that you can find in science and tech, and just all of the opportunities that there are. And we're also very excited to have this event as part of our Big Block of Cheese Day, which is something that President Andrew Jackson did. And he brought in a giant slab of cheese to the White House and invited people to come on and eat it. And just talk about policy, ask their questions. So we are doing a digital Big Block of Cheese Day. We don't have any actual cheese here. Sorry about that. I know. But we are inviting everyone who's tuning into our live stream on whitehouse.gov/live and on NASA TV to ask their questions with the hashtag SoSTEM, which is right up on our screen right here, and also hashtag @the_White_House. So we have some incredible speakers here for you today. You'll be hearing from some folks in the Office of Science and Technology Policy, where I work. We also are so lucky to have Administrator of NASA, Charlie Bolden, here today. And I hope you all have your questions ready for him and some special guests. And then we also have an all-star panel of awesome women in STEM from both the federal government and outside that we hope you're all excited to ask questions. So I want to kick things off by inviting our Chief Technology Officer, Megan Smith, up to the stage. She came to the White House a few months ago from Google, where she helped create things like Google Earth. And so she is an awesome, awesome person to be an advocate for tech in our administration. We're so excited to have her. So without further ado, Megan Smith.
Yay. Science and technology in the house. Welcome, you guys. So I just got to talk to all these cool kid reporters. Do any of you guys read Time for Kids or National Geo? Yeah, lots of readers. Or you read it when you were a little bit younger, because we've got some older kids here too, who are now reading Time magazine and National Geographic. But these guys are doing stories today, so I encourage everyone to talk to them. It was fun to talk to them, and one of the things they were asking me is, well, how did you end up doing this? You know, why did you end up becoming an engineer, and what happened in your life? And it kind of connects to the White House, because when I was little, we had a big energy crisis in the US, and Jimmy Carter was president. And so he started to bring a lot of leadership around thinking about, in addition to oil and gas, could we get to green technologies that would be so great for our environment and also would take us off our dependence on oil over time, which was very expensive and continues to be a challenge for us sometimes. And so he started putting solar collectors on the White House as an example of something he could do. And so I got interested in those areas, and we were lucky. I grew up in Buffalo, so I'm very happy it's snowing because I love snow. I grew up in Buffalo, New York, and there were a lot of different opportunities, but in our school it was mandatory to do science fair. And so I was lucky, because in addition to hearing about science, our teachers, like many of your teachers, would make us actually try it or do it. And so I got to work on solar collectors that I worked on designing and playing with. I made a windmill one time, worked on hydrogen power and other projects. And the main thing I was talking to you guys about, and I think is really important for everybody to realize, I mean, who here knows how to read, right? And who here knows how to write? Okay, so did you know how to write right away? Or did you kind of start hearing about these letters and then writing them out, right? The same thing's true in science and technology and engineering. It's not like everybody shows up and can do perfect projects. You start with forming the letters. And that's true both for learning, but also when you begin a project. So everything from the amazing team from NASA is here. And look at the incredible things they're doing. They didn't start, we started, for example, when we first started getting off the planet, with small rockets and really early ideas and prototypes and playing with that and getting really different cross-functional teams who thought differently to work together. So just always remember, you got to start somewhere. And just like as humans, we crawl, then we walk, then we run, that's the same thing for learning science and technology. The president last night talked a lot about how we're doing as a country. And one of the things that was exciting to see is that we're at an all-time high on sort of our science and math scores. And so you guys are really getting it done, so thank you for that work and keep working hard. You know, science and math is not easy. It takes a lot of grit, but it's really fun and you can do extraordinary things with it. And you guys are going to hear a panel from people who are using coding to help veterans, people are doing things in space, people are doing things with our environment and our parks, people are working, also veterans and amazing work in climate. Nicole's work, Nicole was in the president's box or the First Lady's box last night and is working on sea level rise. We have a lot of work to do on climate change and climate, and so the scientists and things that you can use technology and code and science for are right there. One of the things that sometimes happens is we got mixed up ideas about who does this work. So have you ever watched TV and you're watching the show and the computer science person is always somebody who's not of color, somebody who's always a boy? Did you ever notice that on TV? So sometimes that's like bias that goes on, or somebody might think that just boys do something, or just one group, or one race isn't. That's not true, and it's never been true for all of history. One of my favorite things is in computer science. I got to work at Google, and one time we went to visit England, and we saw this beautiful portrait, and they said, of course you guys know who this is. This is Lady Ada Lovelace. And I said, I have no idea who that is. And it turned out that she worked with this great guy, Charles Babbage, in the mid-1800s. And he got this idea of a mechanical computer, one of the first computers, a mechanical calculating kind of machine in the beginning of what is now, you know, your iPhone or your Android device or your mobile phone. He got that idea, and she got an idea that in addition to what he was doing mechanically, you could maybe program it or write algorithms, what is now computer science. And so there were women and men working together from the very beginning of all of this stuff. Just sometimes it doesn't make it into the movies or into TV, but we're working on that. So the other thing I wanted to encourage you guys to do is to, in addition to trying it, one of the things that we did with the president we were lucky to do was he came into something called Hour of Code. Did anybody in this room do Hour of Code? Yeah, so a bunch of people. What did you guys do? You went what? You went on a computer. You practiced writing code. And what was it like? Was it hard or easy? In the middle. Cool. Yeah. Code.org, right. Uh-huh. So Angry Birds and yep, exactly. So you were saying like the bird was moving forward, and what were you going to say? Yeah.
Well, I was just going to say that it would get harder each time, so I agree that it was kind of in the middle.
In the middle.
But it was really fun.
And did you do things with Angry Birds or do things with other characters?
Yeah, yes, but also recently there's this website where you can code like whenever you want. It's like Lightbot.
Lightbot? Yeah, there's a lot of cool things on the internet that if you work with your teachers and that. So my main thing to you is the same thing with code.org. You want to, and these other sites, just go there and try them. And what you found out, code is just a list of instructions, right? Is that right? So I encourage you guys to get out there, do science. You got some amazing heroes. Some of my heroes are here today. And so I'm going to invite our leader of NASA. We're here with the chief scientist and our overall administrator for NASA. So Charlie, please come and welcome to the world.
All right, my part is really quick. So I'm supposed to welcome everybody and tell you what we're going to do today. We're going to give everybody an opportunity, well, not everybody. We're going to give several of you an opportunity to talk with the International Space Station. And we've got Butch Wilmore and Terry Virts, I think, are going to be there when they come on the screen. So my job is to encourage you to really, if you're not already doing it, really get interested in science, technology, engineering, and math. We had 4 incredible reporters that we were privileged to talk to beforehand. And I want all of you, whether you're in high school or elementary school or whatever it is, to try to get fired up today. Okay, you know, the president talked last night about Orion and its success right at the end of last year. He talked about the fact that we're trying to get people to Mars in the next 20 years or so. And we need mostly this group over here. You guys are getting kind of old. But we can, there's still hope over there. But mainly this group, because you're the ones that we want to get to Mars. So what we're going to do, when they say come up, you're going to come right up here, and I'm going to meet you out here in front of the podium, and somebody will give you a mic. We want you to tell them who you are, what school you go to, and then your question. And you can ask, they're telling me we got 2 minutes, so I got to get fast. You can ask one or the other. They're Terry and Butch. Those are the names they go by. And you'll figure out who they are because they're going to come bouncing out, and they'll introduce them, well, kind of, and they'll introduce themselves to you. So any questions about what we're going to do? Any questions about science, technology, engineering, or math? Who's going to Mars? Yes. Go ahead. Where's my mic? Go ahead.
What are you most excited about NASA doing?
Oh, I'm excited about everything we do, but the most, I always get in trouble as the NASA administrator when you say there is a most exciting thing. Let me say this. The most exciting thing that we get to do, because they let me do it, is come out and work with students like you. That is the absolute coolest thing in the world, to get an opportunity to go to schools and meet with some of you and come and do things like that. That's really, really cool. But we do a lot of stuff in science, aeronautics, human exploration, technology development, and we'll talk a little bit more about it. Question back there. They're going to tell me we got 30 seconds.
What's your inspiration?
My dad. Come on. I grew up in Columbia, South Carolina. My father was an incredible father, but my father was also my high school football coach. And so I was blessed to have the same person be 2 heroes for me, and he was awesome. He was really tough, but incredibly fair. And my inspirations today are my son and daughter. I have a son who's a colonel in the Marine Corps, a daughter who works not very far from the young men back there from Cardoza. She's a plastic surgeon at Howard University Hospital, and so they inspire me every day, and I try to tell them that. And I also have 3 beautiful granddaughters. So I'm surrounded by women in my life, so women in STEM. And the oldest one is a freshman at McLean High School, and she wants to be a rocket scientist. So what else can I tell you? Yes, 1 minute. I got it.
Out of all your accomplishments, which one do you think is the most important or the biggest?
I took part in this, okay? I didn't do the work, but my son and daughter are my most, they are my crowning achievements. My wife did all the work, but I participated. And that's all I'm going to say. Yes,
Okay, it's working.
right there. Go ahead, and you can yell it. I'll repeat it.
What motivates you when things go wrong?
What motivates me when things go wrong? And things go wrong a lot. And I think it's really important for things to go wrong and for you to learn how to deal with them. What motivates me is the knowledge that we can make it right.
We are absolutely ready for
that just because something happened, and sometimes bad things happen.
This is Mission
Okay?
Control.
All right.
Please call the station for a voice check.
Hey, Houston, this is Charlie Bolden. How do you read? Houston, this is Charlie Bolden. How do you read?
Clear. Welcome aboard the International Space Station.
Hey, Butch, how you doing?
We're doing great, sir. How about y'all?
Okay, I'm glad we didn't go through all the protocols and everything, but what I'm going to ask you to do, Butch, is introduce yourself and the rest of your crew members there. Samantha, it's great to see you. This is the first time I've had a chance to talk to you. We have a group of school students down here from elementary all the way up through high school. Any college students? No. And they really are anxious to ask you some questions, so I'm going to turn it over to you to introduce yourself and your crew, and then we'll get right into the questions, if that's okay with you. And tell us a little bit about what's going on today.
Outstanding, General. Yeah, absolutely. I'm Navy Captain Barry Wilmore, call sign Butch. That's why he keeps calling me Butch. And I've been up here for 4 months. I launched on a Soyuz 40S. and was joined by these folks right here a couple of months ago. I'm going to let her introduce themselves.
I'm Air Force Colonel Terry Virts, and I launched in November with Samantha on Soyuz 41S from Baikonur in Kazakhstan. We've been here for about 2 months, and we've been very busy doing a lot of experiments and science, and also getting maintenance done, keeping the space station in working order.
And I'm Italian Air Force Captain Samantha Cristoforetti, and of course I came here about 2 months ago with Terry, and same as Terry, I'm enjoying my time up here, doing a lot of science, doing all kinds of interesting scientific research, and enjoying floating a lot.
Great. Well, Terry, Butch, Samantha, I'm now going to turn it over to the
somebody's got a
students.
question.
We do, and here they come. And you can step right out here. They can't see, unfortunately.
My name is Latrice, and life is life in space hard or is it easy?
Is life in space hard or is it easy? Well, it depends on what you're doing. Some things are, I would say nothing's hard. We're very, very well trained, prepared well for all different aspects, the launching, the different science and protocols and things that we do, maintenance that we do on board station, of course the re-entry as well when we come back on the Russian Soyuz. We're very, very well trained, but days are long, and sometimes they're filled with many, 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 many different tasks. So if anything hard about it, that would be it. Just keeping mentally tied in all the time can be very trying on your mind. But what a great environment. What a great place to work. I mean, you can flip upside down in a heartbeat. The floor is the ceiling is the floor. There is no up or down. And like Samantha said when we started, it is a fabulous time, and it's a lot of fun.
Thank you.
My name is Connie, and I go to Murray Elementary. What is your favorite
You are so
thing in
welcome.
space?
That's a great question, and as you can see, it's so cool floating. You can go on the ceiling, you can go on the walls. It doesn't matter which direction you are. You can just readapt. And after you've been here for a few weeks, you really get used to floating and being weightless. And it's really fun to be able to move around and just kind of, with no effort, flip yourself over like that. And for me, that's probably my favorite thing that we get to do up here.
Hello, I'm Carrie Mullins. What did you have to do to become an astronaut?
Well, there's different paths to become an astronaut. Some astronauts are military pilots. Most of them are also test pilots. Some astronauts are scientists or engineers, and a lot of astronauts have mixed backgrounds, like they are pilots, but they also have a background in science or engineering. Or medicine. You can also study medicine. We have also doctors among our fellow astronauts. So those are main paths. It's important, to work hard in school, to do well. And I like to say it's really important to choose a career, before you become an astronaut that you really love, that you're passionate about, because that's really the key, the secret to being good at what you do. And, when you're good at what you do, then you're also a good candidate for the astronaut program.
Hi, I'm Danny Michaels, and I go to Maury Elementary. Mine's kind of similar to her question. What pushed you all to be astronauts? And how's the weather up there?
Danny, the weather is always clear, so that's a good thing. What pushed me to be an astronaut? I think the biggest desire I had was to do the best with what the attributes that the good Lord gave me, and to try to pursue any and everything that I could. And I wound up joining the military, had a patriotic tug, and as I was in the military, was able to fly, had that opportunity, went to flight school, and once I got my wings of gold, my Navy wings of gold, there was no higher place you could fly or faster to fly than on the space shuttle. So that set that as a goal out there, and thought maybe one day that might be an opportunity. And eventually in 2009, I was able to do that, fly the space shuttle, and then recently, like we just said, 4 months ago, launched on a Russian Soyuz, and here we are now. So I'm very grateful for all the opportunities. It's certainly not ourselves, it's many people involved that actually get us to this point. So grateful to my family and all of them as well.
Thanks a lot.
Hello, my name is Charlotte Basso, and I go to Watkins Elementary. I was just wondering, how do you move around in an anti-gravity environment?
Hi, Charlotte. Like we were demonstrating before, that is something that you kind of need to learn how to do, and you have to learn quick, because as soon as the rocket's engines shut down a few minutes after launch, you're weightless, and you don't have time to learn how to walk. You just have to do it. But it takes a little bit of getting used to, but we've been here for long enough that we know how to move. You have to move very slowly at first, and if you push just with a little bit of force, I don't know if you can see my finger here, but I'll push on Samantha's shoulders, and you start moving. So you have to control how much pushing and pulling you do, otherwise you'll go flying into the wall and hit your head on something. So you got to be careful, but it's really fun, and it's something that the humans can really learn how to do and adapt to. Hey, I have a question for you guys. Anybody go to Maryland schools there? I grew up in Maryland. I went to school in Prince George's County and Columbia, Howard County.
You got a
public
bunch
schools.
of hands going up there, Terry. What school?
I hear some clapping.
Oh, you're going to ask a question. Go
Hello,
ahead.
I'm Labrea from Western
I
High
went to
School.
Fort McHenry Elementary. I asked a question. I went to Fort McHenry Elementary in Lanham and Oakland Mills and Columbia. But I'll let these kids ask some questions. They're more important than mine.
Hello, my name is Labrea. I go to Western High School. My question to y'all is, I heard that y'all 3D printed a tool. How is that going? Did you use it yet?
Yes, we did. We had several things that we printed 3D printer. The 3D printer has now been stashed away, and all of those items that we printed have been bagged up because we're returning them to Earth. They're going to be analyzed, because before they sent that printer up here, they actually printed the same items on Earth that we printed up here, except for one. We printed also a ratchet wrench, and but all those things are going back. I wish I could show them to you. That's not what we printed.
I know, but it's a real one.
Yeah, but yeah, the ratchet wrench we printed was similar to this one, just fairly small, but a ratchet wrench, and it was actually usable. You could actually use it. They wouldn't let us use it. I wanted to, but anyway, those are bagged up and be heading back on the SpaceX, the Dragon capsule that'll be heading back, I think, around the 10th of February. So that's where those are now.
Hi, my name is Robert Golan, and I want to know, how is it like being in a spacesuit when you're outside of your ship or aircraft?
Robert, that is a great question. What's it like being in a spacesuit when you're outside of the ship? You know, Robert, when you get in one of those spacewalking suits, you actually get into a spaceship. It's a one-man spaceship. It's got all the life support. It's got the oxygen that you need. It's got cooling system that circulates cold water so you can stay cool, so you don't get overheated. The only thing it doesn't have inside is food. You can have we have a little water bag, but we don't have any way to take food with us. So we can only stay for certain lengths of time. But it's absolutely fascinating. The view through the visor without having an atmosphere to look through, just the vacuum of space is so clear. And it's just the thought that when you're outside, we never go out alone. We always send two people out. But you think about, you're the only two people in the entire universe that are doing something like that at that moment. It's a pretty special thing.
Hi, I'm Nandini from the Thomas Jefferson High School, and I was wondering, before you first went out into space, what was the thing that intimidated you the most, and how did you overcome that fear?
Well, I can tell you that the day that I went on the spacewalk, I don't know that there was a lot of fear, but even more so, there was a spacewalk by my two comrades, Commander Wiseman, also a Navy commander, and Alex Gerst. They went out on a spacewalk about 9 days before Wiseman and myself went out. And when I suited them up and got them ready, that was the most stressful thing that I have done up here, because their lives were literally in my hands. I had to get their helmets on right. I had to get their maneuvering packs on right. I had to make sure that the depress of the cabin went just according to plan. And that was actually much, much more of a stress, because it wasn't my life that was at stake. It was theirs. And that's something that's a very, very detailed process, getting someone out the door. You know, you think when you open the hatch the first time and you go outside, you've already been in the suit for 5 hours, almost 5 hours, even before you open the hatch. And the person that's doing the most work is the one that's getting you ready to go out. And the next spacewalk, if it goes as planned, Colonel Wirtz and I are going to go out, and Samantha's going to have that task. And I tell you what, I don't envy her, because it is a very detailed, very important, vitally important thing to do.
Hello, I'm Kelton, and what was this a job you wanted ever since you were a kid, or as you got older, was this something you wanted to do?
I didn't understand.
Hey, that's a great question, thanks. Actually, when I was very young in elementary school still, I don't think I was 8 years old yet, I already told people, adults and teachers, that when I grew up I wanted to go to space. And of course I didn't have an exact idea of what it means to be an astronaut back then, but as I grew up and I had a better idea, this thought of becoming an astronaut and going to space actually attracted me more and more. And then I was fortunate enough that growing up I developed mature interests for science and technology and for flying. And guess what? Those are the things that can lead you to becoming an astronaut. So it all came together wonderfully for me. And you know, it's just the best thing that I could possibly imagine doing. So I'm very, very happy.
My name is Nicole Fogel, and what do you think the first thing you're going to do when you get back to Earth?
Well, that's a good question. Samantha and I are going to land together in the same Soyuz along with our Russian friend Anton Shkaplerov. And Samantha and I are going to get on an airplane with a NASA crew of folks, and we're going to come directly back to Houston. But I think one of the first things that I'll probably want to do is get a shower when we finally get to a shower. There's no showers up here, although we have towels, and basically you take hot water, put it in a towel, and that's kind of your shower for 6 months. And it's actually pretty good. We can stay pretty clean and stuff, but that's one thing I'm looking forward to doing. Hey, Butch has a demo here. He's going to show you a little bit of physics in space.
Yeah, I wanted to show y'all this. This is just an iPad. Y'all are very familiar with this. Notice how it's almost twice as wide as it is long, or twice as long as it is wide. So because of that, because of the momentum and how that affects it, if I flip it just right, it will flip twice, and then it will roll the next time, and it'll keep doing that. So let's see what happens.
There goes the roll. It flips a couple times and then it rolls over. So when you guys take physics class, your physics instructors can explain mass moments of inertia, and it's cool being in space because you can actually see it in action.
There you go. Thank you. You can go ahead.
Hello, my name is Jadzia Murphy from Cardozo Education Campus, and I was wondering what kind of work or research are you three doing currently up in space?
Well, it's actually been really interesting. We just had this cargo vehicle arrive with a lot of science on board, and so we've all been busy all day, every day. Even on the weekends, we were doing science. I'm doing material science right now, where they're measuring how materials, as they cool, how they become coarse, and how the molecules inside these melted liquids, as they solidify, how they change. We have a plant experiment in the Columbus module, in the European module down the way there, that's really cool. It's got this big pink light, so at nighttime when you turn all the lights off, the whole station is glowing pink. And we grew some plants. I think today Butch harvested some plants. Samantha was working with fruit flies. We had an experiment of fruit flies. This past weekend I was taking these little worms called C. elegans, and we fed them some bacteria, salmonella and E. coli. So they were happy at first to eat them, but these are obviously things that make you sick. So they're studying how the immune system on the worms are affected by the disease, and hopefully that can help us out on Earth. So the last few days has been a lot of different science that we've been doing. It's been pretty interesting.
My name is Liliana Scott, and I am homeschooled, and my question is, what do you do for fun to pass time in space?
I think most of us really enjoy taking pictures, spending time in the cupola. This is this magnificent window on the Earth we have. We see the Earth from horizon to horizon, so we actually see very well the curvature of the Earth. And of course, we can also see the skies above the horizon. For example, yesterday, Terry and I were hunting for Comet Lovejoy, which is visible from Earth as well. I think it will still be visible for a few weeks, so you can come and hunt for the comet yourself. So we enjoyed doing that last night. I enjoy immensely finding places on Earth that maybe have a special significance or that just speak to me because of their geography and they're so interesting, or most of the time it's just incredible beauty. I mean, it's an ever-changing colors and shapes and plays of shade and light and the sun glint and clouds and a desert and ocean and mountains and plains and snow. It's just an incredible infinite variety that no artist could possibly come up with, and it's just very, very beautiful.
What are you doing there, Terry? You and what's Butch doing?
Actually, he said he could see you guys. He's showing them one of the cameras we use for taking pictures of the Earth. And recently, the lab window has been free. We've been able to take pictures in here. Normally, it's got a payload in there, but so we've got these big, giant, they're almost telescopes here taking pictures of the Earth.
My name is Katie Quinn, and I was wondering, what's the coolest thing to look at in space?
You know, Katie, man, that is hard to pick the number one thing because so many things are cool. And every day it's like, I can't believe I'm seeing this. You're seeing creation from the heavens. It's awesome. But for me, I think auroras. Being from Maryland, we don't see a lot of auroras down there around the nation's capital. And the view you get from here is amazing. You can see them with the naked eye. When you see pictures of them, they're even more magnified. But that is a pretty amazing thing.
Hey, Butch, Terry, and Samantha, I really want to thank you all for the time you gave us today. It was absolutely incredible for these kids. They're telling me you all have to go back to work. So thanks again. Hopefully I will get a chance to talk to you again in a few days. Take care.
All right, super. Thank you, General. Hello to everyone. Y'all have a great day. Have a great time.
And thanks very much, Houston.
Station,
okay, so
Houston
hopefully
ATR.
that...
Thank you. That concludes our event.
Okay. Hopefully that was exciting for everybody who got an opportunity to ask a question. I'm really sorry everybody didn't get an opportunity to ask one. But, there are several things that you heard. One was about studying really hard, about being passionate about what you do down here. No matter whether you know what it is you want to do as you grow up or not. But I think every single person that you're going to talk to on the panel coming up, those that we had an opportunity to talk to earlier, you kept hearing us say that. Just find something about which you can be passionate and then follow it and don't give up on it. You know, the Obama administration is really committed to STEM. And if you've heard the president in the past, he's set a goal of recruiting 10,000 STEM teachers in the next 2 years before his term is over. And that's part of a long-term goal of recruiting 100,000 teachers over a decade. So some of you who are in high school right now, and eventually some of you, may have an opportunity to be teachers or scientists or engineers or whatever. So our message to you, study really hard, work hard. Whatever you do, don't ever be afraid of failure. Don't be afraid of trying something because you think it may not work or you may fail at it. So thanks so much for the time that you gave the crew. They enjoyed talking to you. They always do. And I'm going to turn it back over to the moderator, and we're going to get into a really interesting panel here, and I'm going to listen for a change. So thank you all.
Thank you so much, Administrator Bolden. Let's give him a round of applause again. So awesome. And I know not all of you were able to ask all of your questions, but fortunately, on our panel, we also have NASA's chief scientist. So for all of your space-related questions, you still have an opportunity, which is great. But before we get to our awesome panel, there's another person from my office, the Office of Science and Technology Policy, that I want to introduce to you. Her name is Jo Handelsman, Dr. Jo Handelsman. She is our Associate Director for Science, and that covers a lot of territory. She is a microbiologist by training. Who knows what microbiology is? Okay, a couple people. For the rest of you, I'm really glad you're here. You're going to learn a little bit about microbiology, which is fascinating. And I will turn it over to Jo to do just that, to talk about everything that she's done.
Well, hi, everybody. Do I get a hello? All right, thank you. Well, it's great to be here with you today. I love meeting with students. I used to be, and I will be again, a professor at a university, and I taught students all the time, and now I only get to teach one student, one really, really smart student. Who do you think that might be? The president. He is the best student of science. He loves science. He says he would like nothing better than to talk science every day. He always takes time with scientists to ask questions that totally bowl them over. He asks these really smart questions, and you wonder, how in the world does he have time to read about that, whatever the topic it is, and still be president? I brought a bunch of cosmologists into his office. Anyone know what cosmologists are? Yeah, okay, study the universe. So these are the people that figured out that the universe is expanding. Right? We didn't think that for a long time, and there were a few people who thought that, and they ended up getting a big award. So I took them up to meet the president. And the president sat down in the corner of his desk, and he started chatting with them about cosmology. Well, these scientists were kind of floored, because most people can't even define the word. But the president was very, very fluent in that. So, and that's about every topic that, that you talk to him about. So my next topic that I want to talk to him about is microbiology. So I thought I'd practice on you first and see if you like it. So a few people said they know what microbiology is? Yeah, what is it?
So microbiology would be the study of smaller organisms that the human eye cannot see.
Great. What's your name?
Gabriel Solomon, and I attend Cardozo Education Campus.
Thank you, Gabriel. Good job. Yep, microorganisms are those teeny ones we can't see with the regular eye, but fortunately we have microscopes which magnify them. Just like telescopes magnify the planets for us, microscopes magnify the really tiny things that are right in front of us. So when I was 12 years old, I was in 7th grade, and I took my first science class, and I was really scared of science because I thought it was going to be all electric. I don't know why I thought this. I thought it was going to be all electrical circuits and making light bulbs light up. And I must have read a book or something that had a picture of that in it. So I was petrified to go to 7th grade. My sisters, who were both older, said, no, it'll be okay. You'll be good at it. And I figured, no, but I'll survive, right? And I got into the class, and I realized that this was what I wanted to do with my life. I looked through a microscope, and I saw what's called a paramecium, a little one-celled organism that swims around with these hairs that make it swim. And the best part was that it has a mouth. This is one cell, really sophisticated for one cell. And it sweeps the food in with its little hairs. So we fed it a red dye, and you could actually see the little red crystals go into the mouth as it swept them in. Well, I fell in love. That was it for me. So I was a babysitter at that time. That was my income. And so I saved up all my babysitting money for 6 months, and I bought myself this really, really old microscope. It was actually imported from Germany back in the 1930s, so really old. But it worked. They knew how to grind glass and make lenses back in the 30s, so it was fine. And I spent most of my teen years looking through the microscope when I wasn't in school. And I'd go to the nearby pond and take samples, and I noticed that every time I went, I saw different things in there. And then I would put things from my fingers on and from my mother's hairbrush. And I found things all over that were really fascinating. Of course, I had no idea what they were, but they were cool to watch. So that's the kind of passion that Dr. Bolden was talking about. You find something that you just love. And even though your first impression of that, like mine of science, was all going to be about light bulbs, it might be wrong. You know, you might not really know what it's about. Give things a chance, and then maybe you'll find your passion in there. So we work on a variety of things in the Office of Science and Technology Policy, but one that we're just moving into now is microbiology. And it's not just because I'm interested in it and I've loved it since I was 12 years old. But we've learned a lot about microbiology in the last 20 years that tell us that we, in fact, don't know that much about microbiology. We thought we knew a lot. But what we discovered in the last 20 years is that only a very, very small number of the organisms out there in the world, those little ones that we can't see, will actually grow in the lab. So it's like 1 in 100. So for every organism that we can grow in the lab and that we can study in the lab in a very simple way, there are 100 others, or 99 others, that we can't grow in the lab, and we don't know what they're doing. So that's the future of microbiology, and that's why we need people like you, because we need smart people to figure out how do you study a bacterium or a fungus, whatever kind of microorganism it is, without being able to grow it on a petri dish. That's how microbiologists typically grow things, around these circular discs where they put some jello-like stuff and bacteria or fungi grow. If you can't do that, what do you do besides look at them through the microscope, like I did when I was 12? There has to be more to do. So that's what scientists are struggling with now. How do we study organisms that won't grow in the lab, won't behave like good, obedient organisms? And then what are they all doing? And one of the things we found out is that we have 10 times more bacteria in our bodies than we have human cells. People know what a cell is? Yeah? Yeah? What's a cell?
It's one of the building blocks of life.
Okay, it's a building block of life, the smallest of the biological pieces, right? Well, we have a number of trillions of cells. That's a pretty big number, about 100 trillion cells in our bodies. And it turns out that 10 times more of them are bacteria than human. So doesn't that sort of make you question your identity? Are you really human, or are you a microbe, a really big microbe? Well, that's a good philosophical question, but we're only in the first stages of figuring that out, because that was a surprise. That was figured out quite recently, and scientists said, whoa, there's a lot more here than we thought. And it's only that they're so tiny that we can't see them. Otherwise, they would look like more than us. We wouldn't look like humans. We'd look like a big blob of microbes. But they're really tiny. But there are that many of them. Isn't that amazing? You have trillions of microbes inside of you, on your surface, in your mouth. And they're always changing, and they're always responding. And what do you think microbes do? Here.
My guess would be they can either make you better or make you sick.
That sums it up. They can make you better or they can make you sick. Well, a few years ago, people only thought they could make you sick. Yes?
Once I saw this kind of a video at the National History Museum about it was about things that are too small for the human eye, too big for the human eye, too fast for the human eye, and too slow for the human eye. And there was this part that was too small, and there was this camera that could like see things that were very, very small, and it went like there was like a dog's eye kind of, and it went in deeper and deeper, and I think it's kind of like that.
So you saw something that can see tiny little things, and it can focus in and magnify them more and more and more at the Natural History Museum? That's exactly right, and that's what a microscope does. And now there are lots of different kinds of microscopes where you can see a whole mass of microorganisms, or one, or like you're thinking, even inside of one microorganism. So yeah, we can see them now in a bunch of new ways. And through those new ways, we've figured out that some of them are bad. They make us sick, right? Viruses. Anyone ever had a virus? Yeah? Everyone ever had an earache? That's caused by bacteria? Yeah, so you've been sick. Well, we're always saying germs are bad, bacteria, viruses, those are all bad things. Turns out a very tiny percentage of microbes make us sick. The rest of them make us healthy. And there are thousands and thousands of different kinds that keep us healthy. So microbes are really great for us, and it was only because people were kind of prejudiced against them that it took us so long to figure out that they keep us healthy and not just make us sick. Because 100 years ago, when we first discovered them, we discovered them because they were making people sick. They're making people die, in fact. So scientists wanted to figure out why that was. So after that, everybody had this bias. They had a slant, a view, that when they discovered a microbe, they figured, oh, it must be a bad one, it must make you sick. And it took us about 100 years to figure out, as a result, because we were kind of blind to it, that in fact, most of them are good. So I want to go back to something that Megan said earlier. One of the other things that our office and the Office of Science and Technology Policy does is we study why girls don't go into science as often as boys do. And it turns out that if you look at every measure, girls are just as smart in science, they do just as well in math and science, they have just as much interest initially, but very often they leave. They stop studying science, or they stop going for careers in science. And so we're trying to figure out why that is. And one of the reasons, there are a few, but one of the reasons is people sometimes discourage girls from going into science. And sometimes that's because of a bias. And it's just like the microbes, where for all those years we couldn't see that they're really good organisms because we had kind of blinders on. We just believed all microorganisms are bad, so that's what we kept seeing. And it's kind of the same thing with girls. People have seen boys and men as scientists, right? The history of science is filled with them. You look at the textbooks, you see all these men who are great scientists. But it turns out girls and women can be just as great. And we have to get rid of that bias. So if people tell you girls can't do science, unfortunately, I still hear that, don't believe them. And if you get discouraged, think about, is somebody discouraging you? Maybe they don't mean to, but maybe they're kind of discouraging you from doing this, but this is really what you want to do, so don't listen to them. Go and get it anyway. And remember that sometimes the adults who are telling you what you're good at and what you're not good at and encourage you this way or that way, sometimes they don't know what they're talking about. So sometimes you just have to make up your own mind. So with that, I'm going to leave you with thoughts of microbiology and bias and just take a couple of questions before we go to the panel. Yes?
I had a question about microbiology. How much of what you're doing with how much of what you're doing with microbiology right now is related to microbiomes? Because I know you mentioned the microorganisms that we have in our body, and so I was just wondering how they're related.
So a microbiome, this is a great question. A microbiome is a collection of microorganisms that live together in some place. And the place could be soil, for example. That's one of the things that my research group studies, is the soil microbiome. And that's all the organisms that make soil soil. And then there's the human microbiome. And there are ocean microbiomes, all sorts of different ones all over the world. And it's really funny that you ask, because I'm at a meeting today, the rest of the day, called the microbiome. And that's exactly what we're talking about, is all the different microbiomes there are, and how can we study them together and look at the human microbiome and the soil microbiome and the oceans, and maybe the one on Mars someday, and figure out what the principles are that govern all of them if we do comparisons among them.
If I wanted to be just like you, what would I have to study in college?
Oh, that's nice. Well, first of all, I hope you're not just like me. I hope you're way, way better. So first of all, you have to find people who encourage you. That's the best thing. We sometimes call them mentors, sometimes advisors. Sometimes they're just friends or relatives. But you have to have heroes and mentors who tell you that you can do this. And you can, because science is about hard work. It's not about being some different species or something, which a lot of people think it is, that there are scientists and then there's everyone else. Anyone can be a scientist. It just takes a lot of hard work and wanting to do it. So that's the most important thing, is find your passion. And then for my career, I studied biology. I actually thought I was interested in plants when I went to college, but I wanted to study agriculture. So I studied plants in college, but the microbes kept pulling me back. And so then when I went to graduate school to get a PhD, I studied plants and bacteria that interact. And then I said, forget the plants. I'm just going to go with the bacteria. And that's kind of what I stuck with. So there are lots of different routes to the same end. And you can change careers. You can become a physicist and then switch to biology, or the other way around. So what you really want is a well-rounded scientific background, lots of courses in lots of subjects, because you never know in science what you're going to need and what you're going to draw upon. Does that help?